Let's get to it. Today's lesson is about two very useful testing libraries, and that is Autofixture and Fluent Assertions. We'll talk about what problems does Autofixture solve, how do you generate dummies and test data using Autofixture, how do you customize the data it generates, how do you apply Autofixture for generating mocks for you, and what options do we have to completely eliminate any kind of noise in tests. The next part will be an easier one about Fluent Assertions. How does it compare to classical assertion, and how and why would we care using Fluent Assertions over normal assertions? Let's start from Autofixture. So what problem does it solve? How many times did you have to create an object that is ugly, that just has so many properties, but you don't really care about them? You just create them because your tests require you to. You create that object, you feed it in, the end. When you look back at the test, you see a lot of noise, a big object, and just a tiny line for actually doing something with the system on the test, with the unit. Autofixture solves that problem. How does it do it? Well, look at this. Ugly order class object that is being created manually. We don't care about any of those properties, and the names imply that. We just pass test, dummy, we create an array with a single order, which has an item name called dummy and count one. That's quite ugly. And this line would definitely disrupt readability in tests. However, with Autofixture, we can do something like this. A single line in order to generate an object, a dummy for a test. I hope you believe me now that it does help. How does this work if we want to generate different values or objects? And basically, every time it generates something, it just generates completely random values. And for strings, it will return a property name plus GUID. For bools, it will return true or false. For ints, it will be absolutely random number. For GUIDs, random GUID. And it composes complex objects as well from the stuff, random stuff. And that is Fluent Assertions. The essence of it is to randomly generate data for tests. And in fact, it can even generate services or complex objects with many dependencies, and dependencies even such as interfaces. You might think to yourself that if it generates random data, that kinda sucks. And there isn't much use of something that you cannot control. Well, actually, there are two things that Autofixture offers as well, and that is build, freeze, and inject, which basically makes testing really cool, and it gives you full control. Freeze and inject methods serve pretty much the same purpose. Freeze method basically says that all integers, all whatever generic you pass, will be the same value, no matter how many times you call Autofixture. That specific instance that you froze a t in it. For example, in here, if we look at this part, I froze int, and then I created two numbers. And then I created an order line. And if I were to print what those numbers were generated, it would end up being the same number. This means number 1, number 2, and the order which has a count property, they all will have the same random number, which I don't know, but I could know because freeze returns the number it froze. But anyways, it's consistently the same. And another way I can make the same values consistent by injecting them. So if I say fixture inject 5, that means that anytime anything has an integer, it will be 5. Build is another way of doing things. You can basically use build to create complex objects and exclude some properties. For example, you can say that you want a header with all default values, with an exception for description, that you want to set it to dummy, and you say that you don't want date to be generated automatically and see what happens. How does this happen? You basically call method build, and you pass the generic parameter, the object you build for, and you just play with and without and other configuration options for the builder. And finally, when you're happy with the result, you say create, which executes your configuration and builds the actual entity or object that you were trying to create. And more readable, there's nothing much. Well, here you can see it's just a bunch of unrelated stuff, so nothing there really to compare. Anyways, yeah, this API for building stuff, the whole Autofixture thing, it's bait. Oh, had the long constructor, right? Yeah. It might be just formatting. Like you could just pass in similar formatting as here each parameter in a new line. But I just wanted to have a small line so there is a comparison between fixture, build, create, and my own manual create. That was the whole justification. It wasn't even supposed to be understandable. And actually that just proves the point that it helps. Anyways, that's the API and that's how you create objects with it. And if I create an object here, you will see that it actually created an object with a name, with a description, lines count. So basically, name was a demi value because I didn't touch it. So that's just up to Autofixture. However, description is changed to what I want it to be. Count is 3. Also what I want it to be. And sorry, count is 3 because that's how many elements in an array Autofixture creates. And date is none because I ignore it. Date is none, it writes none because here you can see if it's null, then it writes none. That is how you build with Autofixture. And inject header means that every time I create an order, every order that I create from an Autofixture will have the same description, dummy, and it won't have any date set. There is an even more cool thing with Autofixture. In fact, you don't even need to call Autofixture. You can just pass an attribute called Autodata. And with Autodata, it just injects the values that you pass as parameters to the test method. For example, you're testing a happy path scenario for creating a person. And a valid person is a person who has a name set and birthday provided. And I really don't care what name it is or what birthday it is. I just want to see if I can create a person given I pass any name and any birthday. That is not null. And it literally takes me to write Autodata attribute and theory. And that's it. Just call the create method and you're done. Of course, I can take it one step forward, and you can see it here. It's very similar to inline data. However, there is one major difference. I have two arguments in my function in my test case. However, in this one, I provide only one. And if I do that, it means that the second argument will be auto-generated. So whatever I don't provide is going to be auto-generated. And that is the benefit comparing it to inline data. Which is great, because this further minimizes the amount of code I need to write for just generating or setting dummy values for my test. If I don't care, I shouldn't care. And we can move it even one more step forward, which is mocking. I won't talk in detail how this works, because this is not the topic of this lesson. I'll just show what you can do with it. Basically, there is AutoMock customization. If you say fixture customize with AutoMock customization, it now means that whatever interfaces and other dependencies your service had, it will mock them all. If it's concrete, it creates it as concrete. But if it's an interface, it will mock it. And therefore, if I say fixture create delivery service, and delivery service has a bunch of dependencies inside itself, then that means that it creates actual delivery service, but with all other mock dependencies. By default, I don't need to create mocks, it creates them for me, which is great. In other example, you can see another thing. Here I used freeze method to freeze the mock that Autofixture creates. So basically now I say that if my delivery service had a dependency from courier's repository, by calling freeze method and saying I freeze courier's repository mock, this now means that when Autofixture injects the mock to the delivery service, it will inject the mock that I configure. Therefore, I can do normal mocking with Autofixture, or basically indirectly. So freeze the mock will return the mock, and then we can set it up the normal way. And I can even use Autofixture to create the value that the mock returns. So another benefit. And now we finally have fixture create delivery service with this mock injected. And if I call deliver order address, it will get the couriers that were created by Autofixture. By default, it would get empty array, but with Autofixture, it now gets this, which is probably going to be 3 couriers, because 3 is the number for list that Autofixture uses by default. And we can go even one more step further by having an attribute. So if we look at the step back, here we had new fixture with customized new AutomaQ customization. And in fact, we can do the same thing in the attribute. We can inherit Autodata attribute, and we can set up our fixture in that attribute. And what this means now, that if we, instead of saying Autodata, we say AutomaQ data, it now means that, well, it's set up to resolve mocks by default. And I can provide frozen attribute next to a repository mock for couriers, and which means that I can just grab this repository and set it up the way I want, because Autofixture will create a mock for me, and I will then have to just, use the mock, set it up, and that's it, because it's by reference, so it's still linked with the delivery service. And I can just say deliver order to address. Order, address, the couriers to be returned, delivery service, and couriers repo, all those things are just created by Autodata for me. And I don't even see Autofixture in the test. So this is great. Absolutely zero noise. But wait, there is more. I can set up the mock itself in the setup method for Autofixture, and then my delivery service just call would look like a single line of code. And all the mock specific things are also gone. So now it's very clear that for calling this service, I just need an order and address, and I call delivery service. And I guess you should follow the pattern and keep it consistent, that the system on the test, it should be either last or first, but it should be consistent. And it's really cool. Like, order, address, delivery service, those are the things involved. You don't create them, you just use them. Boom, done. Excellent. And there is no other tool or way of how to minimize this even more. Therefore, Autofixture is the most popular tool of refactoring, minimizing, and cleaning up your tests. However, it is a bit problematic, and of course nothing comes for free, and the problem of Autofixture, from my point of view, is that it adds up to complexity of the test a bit. It's trivial, even though it's tedious, it's still trivial to read and write the dummy values that you create. Read and write the dummy values that you create. It has a lot of learning curve. I definitely agree. But it also kind of screams Autofixture to you, because you have attributes that are for Autofixture as well. So when you read tests, for example, if you look at the arguments that we pass to the test method, we are forced to pass the service itself if we're using Autodata and resolve the service. And this obstructs the normal kind of way you would read the service, because your method doesn't require to pass a service, yet you pass it in a test method. So that is my only issue with Autofixture. And this is just a small price to pay, because the benefits are obvious. And it's great. Other than the Autodata attribute that you can potentially use for mocking, I see no problems with Autofixture. It's great. And even if you don't understand Autofixture now, it's absolutely no problem. I would say practicing a few times, do a few homeworks with it, and you will get the hang of it in no time. Fluent assertions. Why do we need fluent assertions, and how does it look like compared to classical assert? Again, Fluent Assertions uses Fluent API-based assertion style. And this just means that it asserts um, as if a human would read this code, more like it's very human readable. It's not just calling an API, but it's basically a poem written in code. And you read this and you see actual should be expected. When you read assert based assertion, you say assert dot equal expected equal. It doesn't read, it doesn't connect as well. And that's why Fluent Assertions, unlike Autofixture, is making it more simple to read and understand what's written. Um, that's not the only benefit it has. Detailed error messages for string. Well, actually, if you look at the messages for string and um, for fluent assertion and classical assertion, you'll see it quite similar. For list, again, it's kind of similar as well. But now we notice details that we see the count, how many items more it had. We start seeing more details. And if you look at objects comparison, it absolutely dethrones classical assertions. Look at the message that classical assertions throw at you when two objects don't match. Let's look at the test fixture first. I created an order object with all values always consistent. So we create two order objects that are identical but have different references. And then I change the expected order description to unexpected, just to fabricate the expected orders so that when we compare the two, it will fail. The assertion will fail. The assertion fail message is absolutely garbage, in my opinion, for classical assertions, because I cannot read this and I really don't understand what the problem really is. I simply do not know. However, if we look at Fluent Assertion, it's quite obvious what the problem is. And it reads as expected member description to be unexpected with a length of 10, but GUID has a length of 36, and it differs at the start, at the first three symbols. This message immediately tells us what's wrong. Header description is wrong because we changed it. And this is really good because you have details that point you to the right direction, unlike classical assertions, which just say general problem. And in some frameworks, actually, object comparison is not even supported. And in some frameworks, actually, having different debug mode, like building in debug mode and building in release mode, yields different results. Therefore, hands down, Fluent Assertion to make it consistently good. Another benefit, you can even have multiple asserts. If your tests had multiple assertions, which isn't always a bad thing, if the first assertion fails with classical assertions, the second one will not be checked. And we always want to have as much info as possible on the things that failed. And in this example, let's say we have a list and we want to check two things in a list. If it has the item that we want and if it has the expected size. With fluent assertions, with normal assertions, it fails on the first one. and we just see that the item wasn't found. Well, what about the size? I'll never know because it needs for the first step to pass. However, for the Fluent assertions, I have two options. I can either check, I can chain the assertions with and keyword, or I can use assertion scope and have multiple assertions for the same or multiple different objects. And if it fails at the first assertion, it will still continue to the rest of assertions. And so it's much better. Other than that, Fluent Assertion has so many more utility methods for assertions. If you compare what happens when you type assert for classical assert, you'll see that it's like it has roughly like 20, 40 methods. But if you look at Fluent Assertion, it has like 100 of methods for different kinds of assertions. And based on the method you use, you'll have different context. It's not just to get job done, it's to get job done well and to make your job localizing, finding, and debugging, well, preventing you from debugging because you'll know exactly what the problem is based on the error message. And this is especially important when you are using pipelines and when the test fails, not on your local machine, but somewhere that is deployed elsewhere. Simple, easy, and fun. That is Fluent Assertions. Practice and you'll get used to it and you'll love it. That is all I have for this lesson. It was a short one, two very nice tools. I can just demonstrate how AutomoQ works in more detail. This one's not needed. Okay. I can demonstrate the orders example. Here we have our order. Order is made of header and lines. Header has description, general description about order, like what is the order name, what does it contain in description, when was it made, and is it confirmed or not. Other than that, it has lines, and line is just what item it is and how many. And then delivery service. Delivery service works that way that when we deliver an order, we pass an order, an address. So we deliver an order to some address. And basically we make a delivery out of an order. And we notify that delivery is on the way to that address with notifier. Then from courier repository, we check if there's anyone available to deliver that order. And if there's no one available, we throw an exception. If there is someone available, we dispatch a courier from the first courier that is available to deliver a delivery to this address. And we save that we did it in deliveries repository. And how do you test it with minimized noise? If you look at AutomoQ example, to test it, if it throws an exception, if it throws an exception, a bit lost. Don't I have a test for this? Frozen demo. Okay. think I accidentally deleted that method. Okay, it's fine. So let's write a test for a failing scenario, shall we? Cheat sheet doesn't also have it, right? Oh, here. Okay. Here it is. Here we have a method that says delivery service deliver given no available couriers throws exception. Basically, the service fails if when delivering if there are no available couriers. We use AutomoQ delivery service. Basically, we don't have to use that one actually, so I'll just use AutomoQ data. AutomoQ data, remember, it just says we have mocks automatically injected. We have mocks automatically injected. However, we need this mock in particular to have explicit setup for it. We need to set up the couriers it returns. We also need, we actually don't need this. We also need the order it sends, the address it sends to, but those are not relevant. Any order works, any address works, and here we just create a delivery service itself. I put frozen attribute so that the same mock, the same repository for couriers will be used when creating delivery service. And here I take that mock and I set up that it returns an empty list of couriers. So my couriers repository returns no couriers, and thus when I deliver any order to any address, it will fail. If we debug this, you'll see that our setup worked, that any order was created and all was good. Let's see what happens. Let's inspect the order. As you can see, order has absolutely random values that that Autofixture created. And it also has mocks for notifier, sender, deliveries repo, and couriers repo. However, when we get available couriers, remember, we said that we get 0 couriers, so it returns us an empty collection of couriers, and we say, do we have any couriers? No, we do not have any couriers, and it throws an exception. And it threw an exception, and we checked if exception was thrown. And voila, our test passed. Now, if I didn't want an exception to be thrown, I can make a little change. And I can pass couriers array to be returned and created by Autofixture. And by default, Autofixture creates 3 elements. So couriers repository get available couriers will return the auto-generated couriers. And if that's the case, available couriers does not throw. So if all is good, it doesn't throw. And I'll change this to should not throw, because package was delivered. because delivery was sent. I can even specify a failure message. Let's run this. And you again can see that the test passed. If I let's say say that we create a new list, let's make the test fail. Courier, okay, and run the test again. Let's see what kind of message we'll see from Autofixture. Sorry, from Fluent Assertions. And the message that we see is, did not expect any exception, as the Fluent Assertion implies. Because did not expect any exception because delivery was sent. So you can see this part got here, but found exception with message no available couriers because I set it up here. So, yep. Actually, a bit background about this thing. I learned about this thing roughly a year ago. And I also had the same problems as you now have, probably understanding it. Because it definitely wasn't clear to me. And only recently, when I started practicing it, I kind of got the hang of it. And it certainly isn't made easier, because if you try Googling it, there won't be that much of a straightforward answer, and you'll really have to understand what's written and read the full article, and there won't be a quick snippet for this. Therefore, my goal is to also provide a quick reference for common ways of using both Autofixture and Fluent Assertions. Fluent Assertions is fine, it's documented. There is a nice link and all the cases are there. But for Autofixture, it's less covered, and I think now it will be quite good. Let me give you a link to slides. Here you go. And let me give you a link to the repository. Oh no, I didn't make a branch. New. Where do I send this? I send this to chapter 4, lesson Autofixture and Fluent Assertions. Is that correct? Yes, okay. Fluent Assertions and Autofixture examples. Sync, push. Let me get you the link. Yeah, I don't have, because I didn't add them yet. I am slacking. I'll add them tomorrow. Here you go, the link to the repository and all the code examples. Should be good. Should be easy to just copy, paste, replicate, and then finally make something by yourselves. Do you have any questions? And if you don't have any questions, I'd like to ask you to say a thing that you think you understood well in the lesson that stuck to your head. Anything that you see as a highlight of this lesson, or that you liked a lot, or that you disliked a lot. or that you found difficult. Okay. Okay, great. And I agree. Autofixture is impossible to nail it when you hear about it, about all the aspects, but practicing and you'll have it. So just practice and don't worry about it. Thank you guys for your attention and see you next time on Saturday.